All right, so I want to go ahead and talk about the formula because difference of squares in this case is a special type of quadratic expression. And these expressions or this type of expression just has a special formula to it. So in this case, I'm not sure if you guys noticed, but in our previous examples, for example, if I use the x squared minus 9, x squared minus 9, both of these terms in this case are actually perfect squares. Perfect squares in this case are basically a number you multiply by itself. Whatever the product you get is a perfect square. So perfect squares in this case are 1, 4, 9, 16, 25, 36, 49, and so on. So it's basically like 1 times 1, 2 times 2, 3 times 3, and so on. So if we take a look at this here, these here would be considered perfect squares. What this expression is telling you, or the formula is telling you, is that if you have two terms or a quadratic expression, where in this case the first and the last term are perfect squares and it's being subtracted, then you could use a formula of basically finding the square root of each of these and finding your answer. So by doing that, in this case, I have an x squared minus a 9. X squared, square root of x squared is just x. So I could actually express this as x to the second minus square root of 9 in this case is 3. So I could say 3 squared. Once again, 3 squared is 9, x squared is x. In this case, I can represent x being x and 3 being the a. So all I have to do in this case is actually substitute these values, not these, but these ones, into our formula there. So x would be that one, and then the 3 would be the a. So if I do that, my answer in this case should be x plus a 3 times x minus a 3, which in this case is what we had up here. All right, so that's the formula. Once again, it's just another method for you guys to use. Doesn't mean you have